Okay, so with this question we're asked to determine the gradient, which is m, and the y-intercept c in the linear equations below. Now this just comes down to you knowing y equals mx plus c is our gradient intercept form, and all of these ones up to d are in that gradient intercept form in some form or another. So the first one's pretty easy. Your m, your gradient is just 5. It's the x coefficient, so the number in front of your x. And the c is negative 16. Okay. Now, sometimes we might write that one as the coordinate, but if you just say it's negative 16, that's fine for this. Okay, so for the second one, our m, our gradient is 2 over 3, and our c is positive 9. For the next one, our m, now when we write an m, when we've got just sort of a minus in front here, it's simply negative 1. Okay, so we don't write the 1 usually, but it's minus 1. Our c is positive 7. Our m for this next one, again, it's the x coefficient, so it's just 5 over 2. And our c for this one is 0, which basically, because there's nothing there, it means it's going through the origin. Now, it's the last one's the only one that's a little bit tricky. This one's written in general form, sort of. So you've got to get it into gradient intercept form. So you've got to rearrange the equation to make y the subject. So you look at what's happening to y. Y is getting multiplied by 3. It's then having 5x added and 8 subtracted. So let's get both of these over to the other side. Oops. Get both the 5x and the negative 8 over to the other side. How do we do that? We're going to subtract 5x and add 8 over. So we're going to have 3y is equal to negative 5x plus 8. We've then got to get the y totally by itself, and to do that we've got to divide both sides by 3. So when we divide both sides by 3, we've got to divide everything by 3. So what that ends up being is y equals negative 5 over 3x plus 8 on 3. So our m now that we've got it in y equals mx plus c form is negative 5 over 3. And our c is 8 over 3, or if we change that to a mixed number, would be 2 and 2/3.